The simplest way to remember metallurgy forever, one flow chart can save your entire metallurgy chapter. Hello students, let us start. Extraction of some important metals, starting with extraction of silver, process known as MacArthur Forest Cyanide process. Hydrometallurgy meaning in solution form we are using in aqueous solution form, this particular process. From native ore silver, for example, if you are starting with native ore silver, silver along with impurities, NaCN added, it forms one soluble complex, silver cyanide soluble complex. To this, more reactive zinc we are adding. We know silver is less reactive than zinc, zinc is more reactive. Zinc displaces silver and form one soluble complex here, pure silver is outside. So finally we can get here pure silver. Similarly, from silver glans, another ore of silver it is native state, here it is combined form. Ag2S along with impurities NaCN we are adding, it is forming one complex plus Na2S. O2 gas is passed through this solution Na2S, it is forming Na2SO4. So if Na2SO4 is formed, how it is formed? Na2S convert into Na2SO4. The amount of Na2S decreasing here. Why? Whenever oxygen gas is passed through Na2S, it is converted into Na2SO4, meaning Na2S amount decreasing. If Na2S amount decreasing, reaction goes in forward direction. Reversible reaction, right? Forward direction meaning here, automatically more amount of AgCN twice formed. So whatever AgCN twice formed here, when allowed to react with zinc, zinc is more reactive, so it can displace Ag and pure silver get out along with zinc tetracyanide ion. Pure silver that is separated out. Extraction of gold, similar process, that is MacArthur Forest Cyanide process. Gold plus impurities plus NaCN will give gold cyanide complex. Zinc is more reactive, which can displace gold and forms zinc tetracyanide as well as pure gold. So here every time oxidation compulsory, oxidation required in the process. Directive is specified here, so oxidation required. Okay, next, moving further, extraction of copper. From copper iron sulfide, you can say copper pyrites or chalcopyrites. We are extracting copper by using copper pyrites or chalcopyrites. Crushing and grinding of ore, first step, then followed by concentration of ore. Concentration as it is sulfide ore, by using fourth flotation method we concentrate. Then roasting. So roasting, what we do, whenever we heat in presence of oxygen, it gives Cu2S, Fes plus SO2. Further, these two convert into Cu2O, FeO, finally convert into oxide form. But this mixture, Cu2S plus Fes mixture, is copper matte. Copper matte, the mixture known as copper matte. So remember, it is important. Mixture known as copper matte here. Next, by using this copper matte, moving further smelting, Cu2O, Cu2S and FeO. FeO generally associated as impurity. So these two FeO added into the container. Entire this mixture added into the container. Now FeO, basic impurity, SiO2 acidic flux. Acidic flux we are adding into the container. It removes basic impurity and forms slag. So iron silicate formed during copper extraction. Now whatever Cu2O present here, Cu2S also present in copper matte. The Cu2S acting as autocatalyst and converting Cu2O into Cu. Sorry, auto reduction here. So auto reduction meaning here, no external reducing agent, only one of the reactants acting as reducing agent, converting Cu2O into Cu and SO2 gas goes out. Cu is purified by electrorefining. Remember, when Cu is solidified, some CO2 gas is trapped inside it, which is called blister copper. Blister copper meaning the copper which is having SO2 gas trapped in it, that is referred as blister copper. Next, moving to extraction of iron. Over here, hematite Fe2O3, furnace, blast furnace we use, reducing agent carbon monoxide or carbon, flux calcium carbonate or calcium oxide, gangue SiO2 impurity. After concentration roasting of ore, it is melted in the presence of CaCO3 in blast furnace. See, blast furnace is this one. Blast furnace, top to bottom temperature. For example, if you move top to bottom, temperature increases. At the bottom hottest zone, top it is normal temperature. Okay. So here What we do, charge, that is 8 parts of ore, 4 parts of coke and 1 part of calcium carbonate added into blast furnace. So new charge, that is from top side we introduce into the container. In blast furnace, 3 zones available. Bottom zone known as zone of fusion, middle zone, zone of heat of absorption, top zone known as zone of reduction. Top zone you can say around top, bottommost zone is hottest zone, zone of fusion, middle zone is moderately hot, top zone is lowest temperature, zone of reduction. What happens? Reaction C. Hottest zone around 1775 Kelvin temperature, 1000 to 1275, 675 to 975 Kelvin temperature. Lowest portion of furnace, zone of fusion, middle portion, zone of heat absorption, top portion, zone of reduction. In zone of fusion, carbon react with oxygen, CO2 formed. Delta H is negative exothermic reaction. Middle portion, CO2 whatever formed here combined with extra carbon to form carbon monoxide, which is endothermic reaction. Delta H is positive. Zone of reduction, this carbon monoxide react with iron oxide and forms iron and CO2, which is in molten form. So molten iron you will get here. So after completion of reaction, see here, molten iron here you will get at the bottom, molten iron. So you can collect by using this exit. Above this, slag is formed. Above this slag is formed. So here slag is this one, C. In same zone of heat absorption, CaCO3 on heating gives Ca1, CO2. This flux reacts with silicon dioxide gang, forms calcium silicate slag. Iron silicate formed in copper extraction, calcium silicate formed in which extraction? Iron extraction. So slag is formed exactly above the molten iron and it is collected out. Here what we are doing, blast of hot air introduced into this container, blast of hot air. If any waste gases exit out here, from top we are adding charge. Charge meaning all those combination, this one. Okay. Fe2O3 is reduced in different steps. Here we mentioned reduction, right? Take reduced in different steps. First Fe2O3 forms Fe3O4. Again carbon monoxide gives FeO. Again carbon monoxide gives Fe. Finally we are getting Fe. Iron obtained by this process is pig iron, which contains 4% carbon. Hence it is melted and O2 is passed to remove carbon by oxidation. To remove extra carbon, again melted and oxygen is passed. So then pig iron converted into cast iron, which is having 3% carbon to reduce carbon content. Wrought iron is purest form of iron, which is having 0.02 to 0.08% carbon. Percentage of carbon content, pig iron greater than, cast iron greater than wrought iron. Okay. So here next, pig iron, cast iron, wrought iron, percentage of carbon content here. Next, moving further, here one flowchart given for your reference, flowchart for iron extraction. Overall, what we do process overall, see here, crushing, concentration, roasting, then smelting, finally here refining, pig iron, cast iron, refining here we do. Once we are given flowchart given for your reference, you can go through. Flowchart for copper extraction also given, crushing, grinding, flotation, concentration, roasting, smelting, copper matte, Bessemer converter, here Bessemer converter where FeSiO3 is formed, iron silicate, blister copper where SO2 gas trapped in it, refining by using such methods. So one sequence given for a reference, you can refer it. Extraction of aluminium in 3 steps it occurs. First step, concentration of bauxite, Al2O3 2H2O bauxite formula. First step in extraction of aluminium. Under concentration of bauxite, first process, that is Bayes process, which is leaching. Leaching meaning chemical treatment. It is suitable when red impurities like Fe2O3 plus silica present. Red impurities like major Fe2O3 red color which is present, then we use Bayes process. Al2O3 2H2O impurities, along with impurities, if NaOH is added, NaAlO2 is formed, and further reaction with H2O, AlOH rise, on heating will give Al2O3 plus H2O. Aluminum we are getting. Hall's method, it's not leaching, it's not like chemical treatment. So it is suitable when red impurity is present. Like same Fe2O3 red color here plus silica in minute form present. So Al2O3 H2O impurities, here what we are using, Na2CO3 we are using. There we used NaOH, here Na2CO3. So here same Na2CO3, NaAlO2, AlOH rise, Al2O3, similar reagent different here. Surpex method, again not leaching, it's not like chemical treatment, just we are adding substances. Al2O3 2H2O, carbon plus nitrogen. Surpex method, remember, carbon we are adding, nitrogen, aluminum nitride, aluminum hydroxide, finally we are getting alumina. So different, here we are using carbon, nitrogen, here Na2CO3, here NaOH, based on the different. It is used when white impurity is present like silica. Here no red impurity, only silica present like white impurity, then we use this method. Second step, electrolytic reduction of alumina. First, concentration of ores, bauxite we completed first step. Second step under extraction of aluminium. Electrolytic reduction of alumina or Al2O3, which is known as Hall-Heroult process. Important. So you are taking container having here carbon lining acting as cathode, whereas graphite rods acting as anode. Electrolyte is alumina molten, Al2O3, cryolite, CaF2. So together, entire mixture, alumina, cryolite, CaF2 together, powdered coke sprinkled over the surface of electrolyte. Okay, see here some key points. Electrolyte is Al2O3, Na3Al6, CaF2 combination. Cryolite decreases melting point of Al2O3 from 2050 to 950. It increases electrical conductivity. Fluorspar to increase conductivity of mixture, to lower fusion temperature of mixture approx 950 degrees Celsius to 900. So the role of cryolite, fluorspar. See, main role of cryolite decreases melting point of Al2O3 from 2050 to 950. Powdered coke sprinkled over the surface of mixture. Here you can see sprinkled over the surface of the mixture. Role of it, see here. Reduces heat loss by radiation, prevents the burning of anode, powdered coke. Reactions Al2O3, NaL3, Al6, CaF2, dissociation reactions I showed. At anode, O-2 undergoes oxidation forming O2 gas. Cathode, Al+3 undergoes reduction to form aluminium. Keep in mind, O2 produced at anode, that is carbon, reacts with carbon and forms CO2 gas. So it degenerates and need to be replaced time to time. Means carbon converted into carbon dioxide, so consumption of anode, that is carbon, so time to time we have to replace it. Next, Hoops refining, electrolytic refining. Third step, last step of aluminum extraction. Electrolyte is fluorides of aluminum, sodium, barium. At anode, aluminum undergoes oxidation. At cathode, again Al+3 undergoes reduction. See here, it is given. So here, impure aluminum, that is, which should be purified. Here, impure aluminum present. Middle electrolyte, middle layer, fluorides of aluminum, sodium, barium. Middle, based on density it is arranged. Bottom layer impure aluminum, which we are going to purify. Top layer pure aluminum. Carbon is here anode. Then carbon lining is cathode here. Okay, so here reactions based on density. So reactions already we mentioned. At anode plus Al, after losing electrons Al+3, at cathode Al+3 gain 3 electrons and form Al. Overall reaction based on density we arranged these. Next, flowchart given for your reference, that is for just whatever we discussed gave in the form of flowchart. These flowcharts useful for quick revision of such concepts. See, when we use Hall's process, red bauxite like Al2O3 2H2O, major impurity Fe2O3. Then we use Hall's process. Surpex process, when we use Bayes process, Hall's process only when red impurity. Surpex process when white impurity, SiO2 major impurity. Electrolytic reduction, Hall-Heroult process, purification by Hoops refining. Okay. See question here. JEE mains 2019. The correct statement is zincite is carbonate ore. See, zincite is zinc oxide. It's not carbonate ore. Aniline is froth stabilizer. Yes, it is froth stabilizer which can help in production of foam. Zone refining process used for the refining of titanium. No, zone refining mainly used for silicon, germanium, gallium, such compounds, such elements. So it's not like titanium. Sodium cyanide cannot be used in metallurgy of silver. No, we use sodium cyanide only, but cannot be used is incorrect. So final answer is 2. Option 2. Next, Massey refining methods, column 1, column 2. So here Mons process, that is nickel. Yesterday we discussed about Mons process, Van Arkel process. If not watched previous video, once you watch it, previous video. Van Arkel method, like that is for titanium and zirconium, Van Arkel method. Zone refining, you can use for here gallium. Liquation, that is for tin. Liquation, that is for tin. So now if you observe it, one it is liquation, tin, one it is C. 2 it is A, zone refining it is here D. So see here this option. 3 it is B, 3 is Mons process, B is nickel, 4 it is A. So fourth option is correct. If not, watch. In this video we did not discuss about these methods. Previous video we discussed about these methods. Once you watch it, interconnected, that's why we discussed here itself. Okay, see next question. JEE Mains Online 2019. Hall Herold's process is given by. So here everything specified. See Al2O3 carbon. Direct question it is. So above also we discussed Hall Herold's process. Al2O3 plus 3 carbon. Carbon reacts to form Al plus CO2. Okay. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you. Thank you everyone.